Note, this is a spider-heavy article. I can be a little anxious about spiders myself, so my research for this article involved a lot of opening PDFs while squinting and leaning back from the screen. If you're a serious arachnophobe, you might want to skip this one. In the literal sense, this question is totally reasonable, although it would be easy to rephrase it to be completely incoherent. The gravitational pull from a single spider, no matter how heavy, will never beat out the sun. The Goliath bird-eating spider, one weighs as much as a large apple. Two, even if, God forbid, you were as close as possible to one of them, the pull from the sun would still be 50 million times stronger. What about all the spiders in the world? There's a well-known factoid that claims you're always within a few feet of a spider. Is this true? Arachnologist 3. 4. Chris Buttle wrote a good article on this question. As you might expect, it's not literally true. Spiders don't live in the water. 5. So you can get away from them by swimming. And there aren't as many spiders in buildings as in fields and forests. But if you're anywhere near the outdoors, even the Arctic tundra, there are probably spiders within a few feet of you. Regardless of whether the factoid is precisely true or not, there are an awful lot of spiders out there. Exactly how many is hard to say, but we can do some rough estimation. A 2009 study actually measured the total mass of spiders in sample areas in Brazil. They found one-digit numbers of milligrams of spider, 6 per square meter of forest floor. 7. If we guess that about 10% of the world's land area hosts this density of spiders, and there are none anywhere else, we come up with 200 million kilograms worldwide. 8. Even if our numbers are off wildly, it's enough to answer Marina's question. If we assume the spiders are distributed evenly across the surface of the Earth, we can use Newton's shell theorem to determine their collective gravitational pull on objects outside the Earth. If you do that math, you find that the sun's pull is stronger by 13 orders of magnitude. Now, this calculation makes some assumptions that aren't true. Spider distributions are discrete, not continuous. 9, and some areas have more spiders than others. What if there happen to be a lot of spiders near you? In 2009, the Back River wastewater treatment plant found themselves dealing with what they called an extreme spider situation. An estimated 80 million orb-weaving spiders had colonized the plant, covering every surface with heavy sheets of web. 10. The whole thing is detailed in a fascinating and horrifying article published by the Entomological Society of America. 12. What was the total force of gravity from all those spiders? First, we need their mass. According to a paper titled Sexual Cannibalism in Orb-Weaving Spiders, an Economic Model, it's about 20 grams for males and several times that for females. 11. So even if you were standing next to the Black River wastewater treatment plant in 2009, the pull of all the spiders inside would still be only 1/50th 0.00000 takes out of the sun, no matter which way you look at it. The bottom line is that we live our lives surrounded by tiny spiders on a world completely dominated by a gigantic star. Hey, at least it's not the other way around.